Good morning to everyone. Last video we have discussed about the discretization process and factors affecting the discretization process. In this video we are going to discuss about the numbering of nodes and elements. In this, after discretization process, we want to go for a numbering of nodes and elements. So this is the important things for finding the stiffness matrix and then solution of the problem. So that is it. The node and the elements should be numbered after discretization. So that's why once you completed the discretization process, you want to give the number for nodes and elements. The numbering process is most important science. It decided the size of the stiffness matrix. So based on the node numbers, the size of the stiffness matrix will be varying. This is a global stiffness matrix, and it leads to reducing of a memory requirements. So based on the size of the elements and the numbering of nodes, the memory process will be varying, increasing or decreasing based on the number of elements and number of node size. Then while numbering a nodes, the following considerations should be satisfied. That will be an maximum node number minus minimum node number equal to minimum. If you take it as an triangle elements, in this the triangle they're having a 3 corner points. Each point is called as a nodes. If we give it as a node number for particular triangle elements, that will be an 10, 11, 12. Like that we are give it as a node numbers. Because they're having a 3 nodes, we'll get as a number for 10, 11, 12 for a particular elements. In this the maximum node number will be an 12 and then minimum node number will be an 10. So 12 minus 10, the minimum value will be an 2. This we want to satisfy. And then another example is the rectangle elements. Here they're having a 15 elements. Totally they're having a 15 elements. In this, each element they're having a 4 nodes. That node number will be placed in the direct manner, and then the element number will be placed in the inside of the circle. So while placing a element number with help of circle, and then you want to place it. If we placing a node number, directly we want to place it as a node number as 1, 2, 3, 4 like that. Here, for example, we take it as an element 3. The element 3 node number will be an 3, 4 and 9, 10. Here the maximum node number will be an 10 and then minimum node number will be an 3. So 10 minus 3, 7. So that will be a difference of that particular element node numbers. So this will be another one example. So these are the 2 examples for applying an element number and node numbers. Next, selection of displacement functions. So either displacement functions or interpolation function, it is the major criteria to solve the problem and get the result accuracy. So this is the main thing. It involves choosing a displacement function for each elements. The polynomial of linear or quadratic or cubic or quadrilateral anything frequently used for a displacement function, because they are simple to work within the finite element formation. So if we take it as a polynomial function, it will be easy to accommodate or correlate to the finite element functions. In this, the polynomial functions, based on the order, the results accuracy will be varying. If you see, if you take it as a linear polynomial functions, so linear means the power will be 1. So phi of x, it will be in 1D elements. So we will take it as phi of x, displacement at x direction, constant a0 plus a1x linear. So the solutions will be away from the true value. The dotted line will be in true value. The curve will be in the final solutions. So that will be away from the true value. If we take it as an quadratic function, the power will be 2. At the time that final output will be nearly closer to the true value. So likewise, if we increase the polynomial functions, the results will be increased. Thank you.